The first part of an inference test is the state part. We're stating our goal here, and in this case, in a hypothesis test or a test of significance, we're going to state the parameter of interest and the hypotheses. So the parameter of interest is a population measurement. So in this case, we're looking at a proportion. P equals the true long run percentage of free throws made by the player. I'll just say the free throws the player makes, because this could be past, present, future, in general, her free throw shooting percentage. Then we're going to look at, so this is the parameter of interest right here, parameter of interest. Now, the second part is state the hypotheses. So what exactly are hypotheses? The hypotheses are the initial claim and the claim that we're trying to find evidence for, and then the alternate claim that we're trying to find evidence for. So we call one the null hypothesis. The null hypothesis is abbreviated H sub 0, like H naught, like the initial condition. So the initial claim is that P equals 0.8. Here's our initial claim, initial information. We call it null because it's like nothing has happened, nothing has changed. We're saying this is what she says, and assuming it's true, nothing has changed. This would be the claim. Then there is the alternate hypothesis. So the alternate hypothesis we abbreviate HA. So think of laughing, ho ho ha ha. Our alternate hypothesis is that we think the player was exaggerating, so we're going to say P is less than 0.8. And this is what I am trying to find evidence for. Now, I did some simulating and looking at different things, but recognize that we identify or we state hypotheses before collecting data. And this is important to note because in an AP Stats problem, you're usually given the entire problem. Like, here's the question that's being asked, here's the data, now reach a conclusion. But you have to realize that before the data was collected was when the hypotheses were made. And this example, this will be illustrated more by an example in the book that I want to show you. Okay, so just this is important to read in section 9.1 about stating hypotheses. And this kind of just summarizes what I just talked about with the null and the alternate hypothesis and states the claim that we just talked about. But what about there's another type, and this is known as a one-sided, because all we're interested in is if P is less than 0.8. We don't care if P is greater than 0.8, because if she got more than 0.8, then I'm not worried about that. I'm just wondering if she's exaggerating, if her free throws are really less than 0.8. This is known as a one-sided test. Now, a two-sided test is when we are wondering if there is evidence that the null hypothesis has changed in either direction. Like, is it bigger or less than what originally was stated? So here's an example, the juicy pineapples example. It says, at the Hawaiian Pineapple Company, or the Hawaii Pineapple Company, managers are interested in the size of the pineapples grown in the company's fields. Last year, the mean weight of the pineapples harvested from one large field was 31 ounces. A different irrigation system was installed in this field after the growing season. Managers wonder how this change will affect the mean weight of pineapples grown in the field this year. How will it affect? In other words, they're not wondering if it's better or worse, they just wonder if it's different. Okay, and that's the important thing. Notice those hypotheses have to be stated before the data is collected. Okay, so the parameter of interest here is the mean weight of the pineapples from the entire field. Remember, it's a population measurement. Because managers wonder whether the mean weight of this year's pineapples will differ from last year's mean weight, the alternative hypothesis is two-sided. That is either mu is less than 31 or greater than 31. Is it different in either direction? So for simplicity, we write this as mu not equal to 31. So this is known as a two-sided test of significance, or a two-sided hypothesis test when we use this not equal. Words that you should look for is there a difference? Okay, that's the main thing. Is it different than it was before? That's the question that's being asked. Now notice, if we collected the data here and saw that x bar of the data was 31.935, we don't go back and change this to mu is greater than 31. We're still interested in less than or greater than. We've already written hypotheses before the data was collected, so that's important to remember.